Okay, here's a question about an infinite geometric series, and it tells us the common ratio is r, which is the normal letter we'd use for that, and then it talks about the sum to infinity. Now you've got a formula for that on page 8 of your blue formula book, and it tells us that sum to infinity is 5 times the first term of the series. Now just as r is the common ratio, the first term of the series has got its own letter, and you need to set up 5 times that letter equals the formula from page 8 for the sum to infinity, and we need to show that. That means we need to be convincing, and this is our end point. We need to show that r turns out to be 0.8. Now in order to do that, you've got an equation that will have both a's and r's in it. You may need to do a little bit of rearrangement first. You may want to multiply through, for example, to get rid of fractions, but at some point you're going to be able to divide both sides of the equation by a, which is what gets it down to just being an equation in the r, which will lead to this end point here. Now if you couldn't do all of that, you know what r is now, so you have got a re-entry point here, and you can start with r equals 0.8 and the first term of the series being 20. We've got to find the least value of n such that the nth term of the series is less than 1. Now, the formula book on page 8 has got a formula for the nth term of the series, which you can set up. You need to leave n as n because you don't know the value of that yet, but we have got values of the other two letters in that formula, and you can set up that is got to be less than 1. So less than 1, whatever your formula was. Now, if you're doing this question after chapter 3 of core 2 as homework, and you haven't yet done logs, then really the only way you've got to solve that inequality is trial and improvement, which will probably feel a bit wrong. When you come to do the chapter on logs, chapter 6 I think it is, then there's an extra part originally from this question A, and this is part B, and this actually was a question from one of the 2006 papers. I think it was June 2006. No, it was January 2006, and you're probably best off if you're at that stage looking at the January 2006 paper, because part A is designed to help you do this last part here.